Unmute. Can you hear me now? Cool. Good morning, everyone. I'm so happy to see so many of you joining this early in the morning on Terraform. It's a very peculiar topic. I ask you for permission first. GDPR applies, so if you don't want to be in a picture, say no. But I need to prove to my manager that this makes sense, sending me in working hours presenting at conferences. So is it okay if I take a picture of you? Okay. I need a wider angle, and then I'll fall down. Yay. Thank you. All right. Well, that's fine. That can fall down. So as you've seen already, my name is Toni, and today I will be talking to you about Terraform. Why Terraform? Because as the title says, I'm a site reliability engineer, and Terraform is one of the ways we build our infrastructure. It's morning. Let's stretch a bit. Who here uses Terraform? Okay. Pulumi? No one. Okay, cool. I don't. It's a running gag in our office. Like, should we switch to Pulumi every time we find some issues with Terraform? And one more question: how many of you have more than one environment that you manage with Terraform? Cool. So this whole talk is going to be based on last couple of years of us trying to refactor and learn how to use proper modularization and Terraform organization, but I'll be happy to hear how other people do it. Sometimes when you're in tunnel vision and you think the only way to do something is the way you're doing it, you kind of lose some inspiration. So I will be happy if you can ask questions or at the end just share what you think, like, okay, this sounds a bit convoluted, we do it differently. So I'll be happy to hear any kind of feedback on that sense. Oh, I have this. Okay, so what is the problem? The problem is that we want to define our environment, and when I say environment, of course, running production environment, static infrastructure, with Terraform. And we also want to build multiple environments. And then when we build multiple environments, we want to share code. Now, there are many ways to do this. You can do this with workspaces. That's as easy as you can do it. But for our case, we decided to just have a copy of entire structure in multiple locations. So you might ask, okay, so how can this be a problem? How many environments do you have? And the answer is we have a lot. So we have one true production environment, which is also, of course, our test environment. Just kidding. We have 20 staging environments. Does anyone here have more than one staging environment? Okay. Okay, that's actually, I would like to know more. So the reason we have 20 staging environments is because we use merge queues, which means that every PR needs to pass all the green checks in somewhere, and because they're stacked on each other, it would be really hardcore to just go to production with that. So we have so many environments because we use automation. So you enqueue, and then you get a randomly assigned environment, you run your tests, and if it's green, you can deploy. So we have 20 of these environments. Also, some of them are locked from this because teams use it to experiment with something. We also have internal environment. That is just a specialized, smaller version of it, but it shares some of the code and structure with the rest. And we have started to build 3 years ago, and we built it twice already, fun fact, pentest environment. So the idea was that we created a special environment, which is production-like, and then with some different domain, everything is completely disconnected if possible, like nothing should be reused with current setup. And that will be used by external hackers. We had like 30 hackers come in and try to hack this environment and create so many issues that we had to fix them for next 3 years. Yeah, actually, just a couple of weeks ago, we have finally managed to get to the platinum security score, and that happened primarily because we deleted a ton of the old legacy code that was so riddled with issues found in pentest that it was. So yeah, if you want to remove bugs, delete code. That's the fastest way to go there. So yeah, so when we were building pentest environment, we were like faced with the dilemma: where do we copy our code from staging or from production? And then there are some discrepancies between environments. When we built this, so a long time ago, Economic was built with Chef scripts, and then over time it was onboarded on Terraform, slowly migrated, imported, whatnot. One of the things that happened, which was a bit short-sighted back in the day, is when you have in your resource names environment name. So why is that a problem? You cannot just create something new in staging, test it works, runs, copy-paste to production, because you have to spend half an hour cleaning, renaming to make things adjust. This part is not necessarily an issue when it's inside the resource. That depends whether or not this is like in a unique registrar. I'm going to talk about more in the next example. Another thing, because we have 20 environments in staging, to not copy-paste everything 20 times, we used for each. which again naturally presents a problem where you want to compare or migrate changes from staging to production. So that's again one peculiarity of our setup, which we want to go away from. And finally, interesting thing is that when you create resources, and now because you effectively want to make a template for an environment, when you want to name resources, they have to be unique with respect to the nearest parent, which is the registrar. So if you're building a Google storage bucket, the registrar is the world. Basically, all Google storage buckets are uniquely named in the whole world, which means that in that case, it makes sense to actually put staging in the title, because you cannot have service bucket and service bucket, because Google's going to say, oh, you already have it. You can't have it twice. And also, when you have other resources, we use Vault for secret management. Then when you want to templatize things to make them easily discoverable and well-defined, then you end up with structure like this, staging, then this is our environment names. They're all fun, like F1, F2, F3, F5. No F4. Why? Because you'll spend time looking for it. So .po and stuff like that. And then there is a service name, and then the secret name itself. So if you look at this structure, you can templatize it. You say environment type, environment name, and then service name, of course, and then the secret itself. And now I have to ask you, in production, this is production/production. Why? Because it's just simple to have some kind of structure. So that's something that you also have to keep in mind. If you want to start building multiple environments, you have to start organizing all these things. When you use templating, you need to be sure that the next parent can have different named resources. And also, if you have other systems that interact, they also kind of have to support some kind of templating scheme. Cool. So we were looking like this, and we are right now in the middle of transformation from this into this structure. Now, this is not a complication for complication's sake. I'll just walk you through. The idea is that teams can have their own environments. You can always ask the question, when things break down in team environment, who goes to fix it and when? That's a different story. But so teams work in a team environment. They make some changes. They experiment with their infra. Then they promote this change to a testing environment, which is a special one, just to prove that things work. Then they are moved to acceptance and pre-prod, which is basically the set of test running environments. And finally, the one that pays the bills, production. In parallel, we have external environments. External in the sense that sometimes external partners want a stable environment that works 24/7 because they want to be able to test like long-running integrations over the course of multiple months. Our acceptance environments are aggressively scaled down, so when you're not using them, they just shut down completely, saving costs. But external and pen test, for that matter, must live a bit longer. So this all creates like a hierarchy of things to build, and this is the problem we're trying to solve, and now we are looking at how to solve it with Terraform. So what's in an environment? Let's take a look. So each environment, it's basically an environment of economic application, which is accounting application. So we have some global resources, like your typical VPC, the Google Kubernetes engine, our database, which is a huge monolithic SQL server, and also like RabbitMQ, which we use for messaging so far. You can imagine, of course, Kafka and other things being there. And then there's the monolith, the distributed monolith itself, with a bunch of definitions, like service accounts, permissions, pub, sub, those kind of things. We keep only the static infra in Terraform. All the runtime stuff is in Argo, because we use that to deploy Kubernetes stuff. But you still have to define, for example, that there is a Kubernetes service account that is bound to this Google service account that can do read-write operations on these resources. So all this is in Terraform, and that's kind of what you migrate between environments. And of course, a bunch of other services that are not in the monolith, but they're ancillary services. Then we have to look at some requirements, because all design decisions stem from limitations and requirements, right? So what do we use environments for? The primary use case is testing. Is the PR working or not? And remember, when we do testing, we test it in as a whole application. So that's why the whole environment is actually the monolith plus all the services, because when you test, you don't want to say, oh, no, these things are not running, so don't ignore them. They're not mocked. When we, in SRE or platform, want to experiment with something, we want to add a new part of infrastructure or upgrade disks, for example, we really want to do it safely so that we don't accidentally break stuff. So we can use it in production, of course. In staging, because of the for loop, we cannot really change it, because if we change it once, we change it in all of them, which kind of presents a problem. Also, if the product teams want to build new services, sometimes they actually really we empower them to write Terraform. Of course, they don't write it every day, so from that perspective, they always need a bit more help, but they are free to do that. Then also it's the problem when they add a new service, they immediately have to add it to all 20 environments. They don't have like a safe space to experiment because of the whole legacy thing. And again, external partners might want to have their own environments, and compared to these other two, this is very stable environment. It runs 24/7, stuff like that. So requirements for the environments. No team should break others. That's first and foremost. That we had that happening. People would make PR to change something in their infra. For whatever reason, it breaks our staging environments. When staging environments don't work, you cannot test your PRs. When you cannot test your PRs, you cannot deploy to production. So that's why it's kind of like very important that staging are, I usually call them internal production because it has to be up and down. It has to be a stable set because we have to do merge queue and the whole thing. And of course, should be careful about cost, aka we scale down resources when we don't use them, unless it's external system which we want to separate. All right. For external partners, it needs to be way more stable, like much less experimenting. It can even drift behind production for all matters. But yeah. All right. We use Atlantis. Anyone here using Atlantis? So what do you guys use for orchestrating Terraform plans and applies? Do you use it from someone's machine, or do you use Terraform Cloud? Okay. Spacelift, cool. Okay, anything else? ENV0 maybe? No? Okay. So we use Atlantis. This is the Atlantis structure. We have a bunch of them. Atlantis is basically a way to wrap your Terraform and get plans and applies on GitHub PRs. This way, when you want to change something, you send a PR, we review it, and if the plan looks cool and if everything is fine, we merge it. So that's why we use Atlantis on top of all this. So you can see that we have divided it into multiple GitHub repos, and that's going to be important later for synchronization, because you might ask, like, why not a monorepo? And we used to have a monorepo. That's the original Atlantis. The problem with that one was due to the nature of Atlantis. I'm not sure if it's the next slide or not. No, it's after. The nature of Atlantis is that you can only pass one PR at a time, which meant that some of our days as SREs were literally watching GitHub PRs the whole day, aligning them in order so they can go one by one. So this is our structure. We have the Atlanti, plural of Atlantis, anyone? And then we have the modules themselves in another couple of monorepos. This is cut out. It wasn't cut out on my screen, but it is actually. Never mind. So how does one environment look like? So this is just me scrolling down through the environment, so you can see there's a bunch of things. And all of these things are part of the environment. All of them need to be well-defined, well-designed, using well-defined modules, and then synchronized with other environments, right? So as I said, we organize code in Atlantis-something. We used to have this original one, but now we only keep global stuff like Cloudflare's rules or Datadog monitors there, because those don't depend on any environment. But then we have, for env type, we group all staging environments in one huge repo. Going forward, we're not sure how to actually structure it, but it's important to note that we have plenty of those. Another thing we have these monorepos for the modules. We also used to have literally like a single module GitHub repo, but that turns out to be too much work, so it's just easier to organize them. Plus, they change very rarely, and it's usually done by SREs, so it's not a problem. So how does Atlantis look? This is what I thought it's going to be earlier. So when you have two PRs, the PR that comes first locks the state, therefore blocking all future PRs from even getting state. They can't even plan. Only when it's applied and merged, you can actually merge that into the second PR and then continue. So now imagine you have 7 of these PRs in different environments, but in the same monorepo. This doesn't look fun because you have to literally coordinate like a traffic cop, who goes first, who is more important, and stuff like that. So that's why we split it to optimize for speed, and it actually worked because we are no longer blocked by one environment progressing faster than the other environments. All right, so that's how Atlantis looks like. So how did we share code before? I showed you examples of resource naming and stuff like that, and you've seen our Atlantis structure. So our first way of sharing code was copy-paste. I'm not ashamed to admit it, but that was very useful. You test things, it works, copy-paste, rename, it kind of works again, right? Then our second thing, because remember we have 20 environments in a single GitHub repo, was to have internal modules in literally a folder called modules in the root. That was fine as long as the modules were only used in that GitHub repo. The problem became when we wanted to use the same modules in multiple GitHub repos. Again, every design choice comes from requirements and limitations. We chose to have multi-repo setup. If you don't choose multi-repo setup, then I think half of this talk is much easier, because the biggest problem is sharing modules across multiple GitHub repos. And like I said, I would like to get some perspective on how you guys do it, because I'm kind of, after watching this for the last couple of years, I think that's the only way to do it. So please help. Then another thing you can do is you can use external modules, so you can put them in a Git repo. Of course, you can also use some Terraform registries, but that's a bit, we found that to be too complicated, because Terraform has a built-in support for locating Git-based modules. And our biggest challenge was moving from monorepo to multi-monorepo. Again, why multi-monorepo? Because we structure multiple environments in one. So imagine there's a team that wants to have 3 environments, because they're a big team, they do a lot. So they will have their own monorepo of 3 environments in one repo. All right, so I talked about our requirements. Let's talk about what the modules actually are. But I guess you know, so just a quick, a recap, because I think the reason why I put it is that it will explain some of the design choices later. So as you know, it's just a folder with Terraform files inside. Everything is a module, even the root modules are technically a module, right? So yeah, it's just a folder with TF files. That's the definition of a module. And then this is variables file expanded. So every module should be designed to abstract and hide the internal implementation to the level where it actually only exposes what is relevant. So this is our networking module, very straightforward, doesn't really require much. And when we build, for example, the VPC, right, we use typically variables with some defaults, for example. The reason why we have name overrides is because I showed you earlier, when you name your VPC economic dash production, that thing is going to stay. And if you want to call it economic, because why not? It's locally scoped to the GCP project. It doesn't work anymore, because then you cannot write templating very easily. So we have this definition: either choose the environment name, or prefer override if specified. Right? And of course, you can always have some variables fixated, because if you make everything a variable, then you're becoming indirection layer on top of something. So at some point, you need to decide something in your module, right? So this is how you would use it inside. And from the outside, when you use module, you have special keyword. The source in this case is, as you can see, it's a monorepo for modules. Then there is a folder called networking, as you saw it on the previous screenshot. And then this is the version of it. So we use versioning to tag correct modules. Fun fact, every branch name is also a version, which will come in handy later. And then when you initialize a module, you basically just specify variables. You might look at this and ask, again, variables? What is this? Matryoshka dolls? We have them here, then we have them here. Did we decide anything? And here's the important part. This file is also part of the syncing process. And if you think about it, if you want to use networking in 3 environments, it's going to look the same, right? There is hardly any reason not to look the same. And then you can see that we have some locals, we have some variables, right? Where basically we're trying to extract all the possible configuration out until it's well-defined. So yeah, what are the benefits of modules, right? You probably know them, so I'm just going to go quickly. Isolation, componentization, and reusability. Also, idea is to hide complexity behind the simple interface, which is not always easy, because sometimes there are leaky abstractions. And of course, you want to enforce security and best practices, because then the developers just consume the building blocks that you build for them, and they don't need to think about, oh, should I use, I don't know, Istio injection or ambient mesh. They don't decide, they just use what you give them, because as platform engineers, we decided for them. However, there are several issues. This is actually our 3rd attempt at using modules, and I think we're kind of happy now with it. The biggest problem with modules is that, first of all, they're remote, which makes changes in them a bit hard. If you change something in a different repo, how do you see if it's working, right? You need to apply it somewhere. I'm going to show you actually an example of how it works today with our system. Then it's a leaky abstraction. What does that mean? when you look at the variables that the module asks you to fill, and when you look at the outputs, what the module gives out as a result, quite often is the case that both of these are actually just in direction over the underlying type. So if you look at this one, right? So this is the definition of a module. So this is input. You need to okay, you can say that because we generate name from environment, you specify environment, you're done, right? But at some point, if you look at these variables, what is the peering name? What is the proxy subnet name? What are the limitations on, is this string? Is it a number? If it's a string, what's max length? Why that one? Then you have to basically go to the usage and then realize, oh, this is just in direction on the underlying property. Basically, the consumers of module actually need to understand what was this interaction about, and they have to go to the Terraform documentation, find the original resource, the one that's abstracted, so it's not really abstracted, it's now indirected. And this is kind of a problem. Lots of these internals bleed in and out through these variables and outputs. And we found that to be very subpar because one of the ideas was that we hide the complexity of the cloud for developers, but turns out in certain cases, you kind of need to understand why things are there, and you have to actually go to the original resource, which is not obvious, because when you look at the variables, you think, oh, this is a variable of a module. No, it's just the indirection on the different input on a resource, and you need to go to that documentation. So documenting that becomes a bit hard. Naming is always a problem. Do you want to be very specific? Do you want to be very abstract? We don't do multi-cloud, but imagine if we want to do we prefer having Kubernetes as a name of module so that later we can switch, right? Or do we just go with GK because we are on GCP and we're not going to move? Another one is how fine-grained should the modules be? We had, for example, a situation where we thought about creating a module for building Google Storage Bucket, but turns out it was a single resource with 20 parameters that are just basically variables filling in. So you're like, okay, it doesn't make sense to abstract because it's not abstraction, it's indirection. So rough rule of thumb is if 50% of the, if you look at your module insights, if you have more than 50% of all the inputs, basically variables, it's indirection. You didn't really decide anything. You just basically collected some resources in a group, and so it's kind of like, how do you deal with that? I'm going to show you later what we did with stacks. Of course, there is another issue at scale when providers have breaking changes. We had that recently. Cloudflare moved from V4 to V5, and they rebuilt their entire API, which meant that everything that uses Cloudflare, and which is every single repo we have, we had to kind of move forward. And with modules, it's a bit hard because if you have an environment and you saw the scroll earlier, right? You kind of have to fix all in one go. There is no way to fix it piece by piece, because, I mean, you could do versioning, but then providers are actually global to the module. It's a mess. So breaking changes become a bit of a mess, especially if you have cascade modules, which I do not recommend. That's when modules reference other modules inside. Don't do that. And finally, creating, destroying, and migration. So creating a module inside a particular stack or environment, destroying it, migrating, it becomes a bit hard because there are certain things with providers, which I'm going to go into more details later. So these are some issues, but we decided that they're not truly issues, but we have to acknowledge them because they affect, for example, leaky abstraction affects our documentation and training, because we have to tell people, okay, so this is that to keep in mind, right? So naturally, when you start using modules, your infrastructure can be drawn like this. I'm going to walk you through. So there are two lines, three sections. First section is infra. That is basically what SREs and platform control. It is the underlying foundation of everything. It's app agnostic, if you want to think about it, right? It's not for any, it's for all apps. Then we have this app layer, which consists of two parts. The first one is the application infrastructure. For example, it's Cloud SQL or Mongo database. And then the application resources itself. So let's take a look from the top. You have VPC, which is the foundation of everything. Without VPC, you don't have compute. Then, after VPC is constructed, you have the next layer. There is a reason why these layers exist. So RabbitMQ is inside this VPC, GK as well. Mongo has peering, that's a different story. And then the RabbitMQ is just an instance. It's just you say how many instances, what is the compute class. But then we want to specialize it. We want to create a vhost. We want to create some permissions. We want to do a bit more specialization. Same with GKE. This is just raw GKE, right? Just flat. Then we need to configure it, install Datadog, install Argo, install whatever we need to get the bootstrapped GKE ready inside. So things like Helm charts or anything that we create after the fact. And then each app consists of, well, ideally apps are stateless. They just have the Kubernetes stuff. But quite often they have stateful stuff, pub sub definitions. They have Cloud SQL. They have Mongo database and all that. Okay, cool. Why are there arrows here? Why is this not a single module? Why is this not a single module? Why did we split it in two modules? So the answer to that is providers. Providers in Terraform, I'm not sure how much fun you have with them, but providers are a bit of an issue. And they kind of forced us to build it in this way, because if you won't construct these things, because they're constructed from previous resources, at some point, providers create an abstraction point. Let's move on. I'm going to come to them later. There is another thing with all this, is the hidden modules. So even if you look at all this all has to be defined and configured somewhere, right? And basically, the TF file itself becomes something that is, we don't have a name for this. It's not a module. We decided to name it stacks. I know that there is a word stacks already used in Terraform world, so it's not, maybe a bit ambiguous. But basically, the file where you do the module invocation and configuration itself it's not really a module, but it requires syncing. And also, there's a problem when you make a breaking change in a module, you have to update the invocation. Like if you add a new variable, you have to go into each module invocation and add this new variable, stuff like that, right? Which kind of brings us to the point where we want to extract common variables into locals and non-TF files. Let me show you how that looks like. First of all, this is one application. So this is app_identity server, doesn't really matter, but this is the file inside the environment. And again, this file is the same in multiple environments because there is no need to really change that much. So the whole point here is it's all collapsed. It's 328 lines of code, which if you copy this from one environment to another one, you're kind of ready. And it uses 3 different modules. It uses module for the Kubernetes. It uses module, doesn't really matter, module for RabbitMQ and module for Cloud SQL. And then it has a bunch of smaller resources because remember, at some point we were like, okay, how do we modularize this? It's just easy to have inline resources. And then you get this, and then you have to think, okay, maybe there's a better way. But usually, it's better to just try something simple and then let that one decide, let that one guide you towards design. Cool. So what do we now think when we see this? We take a look at this is, I should have done animation. Basically, it's this module here. I'm just expanding it for you to see why is it actually important to synchronize. So again, this is a module. It's actually using its PostgreSQL module, basically creating the database. And it's again pointing to the externally hosted module, which is versioned. And now if you look at all these things, right? Some of them are hard-coded because there is no need to have an environment where this is not true. But we have forwarded or extracted all of the configuration outside, right? But still, if you think about it, again, this file is suffering from the same problem of module synchronization. So what we wanted to do here, we wanted to have a fully configurable environment. And we want to have multiple layers. So there is the layer of environment itself, like what am I staging or production? Then there is the environment itself. Then there's the GCP, which is the global, our folder. If you use Azure or AWS, you have the same equivalent. And then we want to have like individual environment stuff. So basically, we have multiple levels of configuration. How does this look like? Inside each repo, we have multiple files. So one is global TFRs, where we define global things that basically all things inside this repo will follow. Then we have this particular production environment has this configuration, and we can have also per app configuration, which is then specialized. So if you're an app operator, you can always just compare configuration in this environment, which is usually here. Because ideally, this part is exactly the same across environments. Because if it isn't, how would you synchronize it? You would either risk drift or manual comparison, which is something that I do not recommend. So this is how we force ourselves to extract until basically all the differences are accounted for, which might not always be easy, which I'm going to talk about later at the very end. Okay, so how do we organize modules? Again, as I said, we can do it inside the repo, outside the repo, and use Git submodules. Do not use Git submodules, please. External modules, which is what we decided, or Terraform registry, we tried, it's just too verbose, wasn't worth it. So when you can either have this local path, or you can have a monorepo where you specify a subfolder, or you can have just a simple singular repo for a module. So right, versioning and promotion. I'm going to show you a small demo. I think it's actually even after this one. So whenever we want to change something in a module is disconnected from any environment, right? It's used by multiple environments. It's a bit hard to figure out what does it work or not. And then when you're happy, you need to promote this to all the other environments so that it gets synchronized, right? So let me just show you quickly. Let me see if I can type under pressure. Already at the wrong place. Cool. So this is, for example, this is our monorepo where we define shared modules, and I'm just going to quickly edit one of these. Let's add. Doesn't really matter. I told you I can't. Let's just do this. Doesn't really matter. I'm not going to merge it nowhere. All right. Test. Cool. Create new branch. We should do branch protection here. Let's not talk about that. Okay, so I'm going to create a new pull request. So remember, I'm in a module. How do I know if things work? You can't really know. There is no plan, right? You can't plan it. Now, you've seen how many environments we have. We are still in the process. We literally now, our next 3 months goal is to recreate all 20 environments from fun names to something slightly more professional. So we're going to have to work on the proper, fully automated flow between all the, all the environments. But right now, we have this setup on the pentest environment. And if the demo gods are on my side, okay, so we are now doing, creating a test PR in a different environment where we basically will get a plan and we can actually testing. So the idea here is that whenever you have a model change, you want to have an environment where this will actually work. You can, of course, always pick one and do change there. You can also create a PR. You can also create a branch in this repo and then manually reference that thing, but that's not fun. Why do stuff when you can automate? So now the comment, I have a new update to this comment. And if I go to this other repo, you can see that it was an automated change. It links to the source PR, which is the one I just created. The branch name is, yeah, of course, generated. And the file change is nothing but version change, of course, because it's only used once. If it was an app component that's used multiple times, you would get it. And then finally, it's a big repo. But now I can actually see the plan. And of course, if I find something that's mistaken, if I update the original branch, I could just do Atlantis plan again and then see the new change. So this kind of workflow helps with seeing the changes. And of course, we are missing the next step, which will be that once this PR is merged in the test environment, you have proven it works, you get multiple PRs created in all other environments so that we eventually bring them all into sync. We have also decided to do eventual consistency between all environments. We're not really forcing them to be exactly the same on day one, because some teams can ideally lock themselves, say, like, currently we're experimenting, do not merge stuff in our environment, because it's not really necessary for us. But yeah, so we don't immediately create PRs in all environments. We just do one by one. Okay, so you can see here that, okay, the Terraform always finds something unnecessary, and then you can see that this is the change that I just made, right? And now, of course, I can either experiment more or merge, but basically this is the workflow for working with modules, which kind of makes nice DevOps, because you can see changes somewhere, right? So yeah, so versioning, make a change in the modules monorepo, test in test environment. But then we have this, not every problem is technical, some are socio-technical. It's who's responsible for the PRs, right? So we have the concept of on duty, like is the person that's on duty, are they supposed, what's their ETA? You know, what happens when people forget? You know, it was Thursday afternoon, somebody created a test, they tested it. Now, you know, it's Friday, then Monday. When do we get to merge the rest of the PRs? So that's something that we need to solve as an organization, and I think that that's just a natural way of attacking this problem. It's not just technical, it's also like pragmatic. There's also a problem that we haven't yet encountered, but it's always in our mind, which is the handling conflicts. Basically, if two people have changes in the same module, which order do we apply them in? Can we verify that when we test them, that they're tested truly together, not like one was tested, then another one was tested, but they're never merged and tested it together, stuff like that. And of course, stale PRs, which just go to die somewhere, and we have to address them. Right? In general, it's very easy with versioning because you can just bump the version, and then if you want to do drift detection, you just clone both repos, scan all the module usages, and just see if there is anything that's out of sync. So that's one way that we want to attack this problem of version management. Another thing we can do is to manually promote, which is basically ad hoc decide that we want to promote a change from one environment to another environment, which basically looks like this. You just pick destination repo, and then this gets applied there. That's also a way to go, but it's not the best because it can cause drift. We can forget environments. Like this dropdown itself, like, is it up to date? Once we add new Atlanti, it has to be here, right? And again, if somebody changes module, yeah, there are stuff that can happen here. So what we need to build, and I think that's something that everyone needs to build at some point, if they have this kind of eventual consistency, you have to build drift detection, because otherwise you will not know when do you actually need to do it, and then an easy way to click sync or to create a PRs that will just apply the things and for you. All right. Then when you're working in modules, this is also not the best developer experience, because it's still disconnected, right? You're writing ad hoc Terraform that you don't know if it's going to work, and waiting for plan to plan. It's not the funnest way, right? So ideally, if you want to have a supreme developer experience, you want to have local code in the repo, not the Git ref link, but literally local one, because then you can do linting, formatting, and validation, right? And then when you push to remote, you can actually get plan, and it's faster to iterate. I actually have a demo, so this is kind of fresh off the presses. I'm in production. I'm going to zoom in, don't worry. OK, so I'm in production. Let me verify there are no changes. They're here. OK. Cool. So what I want to do experiment module, right? And now it's going to list all the modules I'm using in this repo. And I'm going to say, you know, I'm not really sure if the Kubernetes environment is, you know, well defined. I want to experiment at, I don't know, something Kubernetes specific. So I pick 3 down there, which module. What does it do? It basically finds first of all that repo, clones it locally. Now it moves the module to your local system, and you can see it's now here. It's in modules. It's pulled locally, and then in every single invocation, it replaces the call from going to the monorepo to now local. Cool. What does this give us? So now I can do cd envs production, and I can do make all, which is basically make lint validate format, and then you can see that. So this flow is a much faster flow, because you can actually have in-place developer experience rather than doing it across repos, waiting for things and then guessing. And when you're done, you can just experiment restore. Why don't I remember stuff? Restore modules, of course. And then I'm done. And now it basically reverses the whole thing, and I can actually move on. So that's actually the best way to do Terraform, in my opinion, because you have, you can do local linting, variable formatting, the whole thing. And then when you get to the plan stage, unfortunately, I cannot plan on my machine because the secrets are forbidden from my machine for obvious reasons. But yeah, it's much faster workflow, and you can get into the state where you know whether or not your module is functioning much faster. So this is our prototype for how to work in the best possible way, but it still works if you just do it the way I did earlier, when you just create PRs. But you can see how this is a bit more guessing, because the only time you realize are you doing something correct is at the very end, when you get the plan, which it took time. All right, so that's one way you can get local experience. Cool, we have two more things to discuss, which is going to be stacks and how do you get from something that you have that's not on modules to modules. So this is the final workflow that we will use for promotion. Teams work in their isolated environments. They send reviews to the special environment, which is called testing or pre-acceptance. This is the bottleneck for SREs. Luckily, we anticipate not that many changes because static infra doesn't change that often, like per team once every half a year, so it's fine. Then after automation goes, updates things in some central location. Basically, it distributes the changes to all environments, which are all PRs, which now we have to answer the question, who gets to merge them and how. But yeah, this is the ideal flow. And it works both for promoting version changes and for promoting stack changes. So let's talk stacks. This is the image I showed you earlier. And I told you that when you look at the one vertical, it is still encoded in a TF file, right? And the reason why this break is necessary is because of providers. So let's take a look at, again, the identity server application. So we have a module, it doesn't really matter what's inside, but it's a module that creates PostgreSQL instance. In particular, this provider that we use for PostgreSQL is now initialized. How is it initialized? It's initialized from this module, which means that technically speaking, you need to first have the instance, and now you create a provider on the instance, and now you can actually use things with this provider, like, for example, creating database tables, grants, user stuff like that. Why is this a problem? This is a problem because you cannot plan this in one go. You cannot apply this in one go. Worse, if you delete this file, it will actually not work. If you delete this, comment out the file, it will actually not work the way you think. You'll get an error from Terraform saying that the provider has been lost. This is very common for Kubernetes or Helm, right? Helm providers and Kubernetes providers both are initialized from an instance of Kubernetes, which means that in one go, you cannot both create a cluster and install Helm charts in it. And vice versa, you cannot delete both in one go. You have to do it in multiple cascading PRs. So basically, when you copy this file from one environment to another environment, and you want to say, cool, let's create a new app, what you need to do is manually comment out half the file, apply with no merge, plan and apply with no merge, then uncomment things, and you do it as many times you have providers in the file. Because every provider is a cut, right? Because provider is only valid after the module, after the instance or resource is created. Not all providers are like this. Some providers are global, like Google provider is global because it's initialized by the cloud, so it's fine. But these are like local relative resource initialized providers, and they break our things. So that's why we end up having this structure, and that's why creating an app with a Cloud SQL takes 2 PRs, and deleting an app with Cloud SQL takes 2 PRs, because you cannot just, this is not a dot, this is a mouse cursor, sorry. You have to do it in 2 steps. So that is kind of downside of this approach, and again, this file needs to be synchronized, which means if you ever introduce something that has a provider in your new app or existing app, you suffer the problem of it's not actually straightforward to copy this into another environment, run Atlantis plan, and apply, because by definition, it will literally not work. You have to do manual stuff. So at some point, even with all the automation, you will fall back to some level of manual approach. Yeah, so stacks, we call stacks those TF files, because again, they're huge and they are self-contained. They require promotion. And then what we realize is that not all files require promotion. Some files in production are really only in production, they will never be in staging, and vice versa. Some support stuff in staging is only in staging. So we built this like just cool extension.local.tf because our syncing tool ignores those files. So this way we can say that, skip this file. We also learned that there are files that are actually similar across all staging environments, but not with production, and we have a difficulty naming that, because ideally we want to synchronize those files between the environments, but not up, and now it's becoming a, we have to build a mechanism for that. And one key thing, the stacks, the files themselves, should be identical, because if they're not, you cannot sync them. You have to, it's really hard to define an algorithm to merge two arbitrary HCL files. This also forces us to do one thing. It forces us to abstract as much configuration as possible from a stack so that the full configuration is actually external. So for example, Identity Server has special variables for itself, which is in the file itself. And then it doesn't really matter what they are, but you can guess that backup in staging and backup production, not the same quality level. And then it's actually defined in the environment local TFR, so in production, this is the configuration. So this way, again, application operators can just go into one file and see this, and if they want to compare different environments, we can now even build automation where you can download, git clone to repos, get these files, do match, and even tell you how much they diverge. It's now easily possible to compare environments fully across multiple apps, because again, stacks should be identical. However, that's not perfect, and that's why you need drift detection and also promotion. So this is just an example of the very long stack diff tool. I can actually run it probably for you now. It's not really that flashy. Yeah, this one. Yeah, so let me just zoom in a little bit. And also that don't have colors when I do it like this. So it goes through all the files and just complains about small differences between two environments, right? And at the end, you get some kind of summary that you can see that it's comparing these many files, and then it found some files in the first directory, found some files in the second directory, so it's forcing us to either put .local to make sure that they're specific, or synchronize them, duplicate them and make sure they're the same. Eventually, this should go down to 0, and this difference should go down to 0, because yeah, why are the environments different? That's an important question to answer. Otherwise, this becomes just a tribal knowledge / that person is now on vacation. We don't know why that's there. So yeah, so that's something we have to build as well, just to figure out. And sometimes things are really hard to do because modern environments have modules for a GK, but the production, unfortunately, is built anciently, and it's not every time easy to port your existing code into modules. Yeah, so this discrepancy is a bit hard to actually untangle, to be honest. So we'll see how to solve this one. And sometimes it's just as easy as swapping positions, right? So this is basically, you can see it plus minus, it's the same thing, just not in the correct position. So you need to build this kind of drift detection. Synchronization is super easy. Literally just splat the files over, because that should work, right? So from the source to target, just paste all different files and get plan, and it should work. So that part is, I would say, more straightforward than modules. Again, the only problem that you can have is introduction of a new global configuration that you have to also address here, right? So if a new app comes alive, or the existing app gets more configuration that's mandatory, then this block, which is per environment, now requires manual change while doing the stack sync. But at some point, some breaking changes are unavoidable, so just deal with them, so it's fine. Cool, and our final topic is how do we migrate there? When we started this effort 2 years ago, we had staging and production completely dissimilar. The amount of differences was staggering. Now the amount of differences is basically very small. You've actually seen the differences. Those 15 files, that's the difference, right? But we had a production system that was working, and we spent full quarter this year literally defining the modules, aligning them with the existing design, but also thinking ahead, and then migrating the current things into the module design without downtime, without basically service windows. That was for us important, because no one wants to be late at 10 p.m. Doing, watching Terraform plans and applies. It gets boring after a while. So yeah, so how do you migrate the modules? First of all, you need to define them, right? You need to see what your ideal module looks like, and then you take a look at, the file before, file after, and now the fun begins, because Terraform knows what resources are. These are the resources, they exist, They're accounted for. You bring in module, and Terraform's like, cool, I want to build new resources. And you're like, no, they exist already, right? Let me tell you how they map. So there are two ways to do this. The first way is with imports. Basically, you take an existing resource. In this case, this was basically the full name was Google Compute Network, and then network was the name of the resource. We created a new we have now a new module, which again, it's not new. We're basically remapping the things that already exist into the module, so they should not be created because they already exist. So we create this import block in Terraform, basically mapping the existing into the module. And you do this for every resource ever, right? What happens is that now you have two ways, like two different owners of the same resource. So at the end, you need to do state remove in Atlantis and delete the old resource. So that's one way to do it. The other way to do it is to use moved blocks. Again, same story, but it does, unlike the previous one, doesn't require a state remove, which is much better because you don't want to mess that one up, or you don't want to blindly trust that it works exactly as it says. Moved is much better. Again, same thing. You move the old variable into the new one, and then you have a second PR that deletes the old resources because this internally switches the owner, so it's actually fine. So this is we use both approaches depending on where we were, but basically this is a way to get from the existing infra in just resource land into the module land. Yeah. Some limitations when importing are that when you have naming, like with dash production, as you saw, it becomes you can't really rename. By renaming, you have to create new and destroy the old one. Sometimes that is really painful, like VPC, which is the foundation of everything. You would need to spend so much time trying to, you need a downtime for that, right? Because you need to create everything, map it over. And that's also one of the problems with our GK. Our GK is done the old way, plain resources. And now with modules, the discrepancy is too hard, and we don't want to do slow migrations because that requires having two applications in two different clusters. It's too much work. Another thing is you might want to do name templating. You want to have your module called Kubernetes app. And what's the service account name? It is the service name dash environment name. Cool. And then you hit the resource limit. So for example, Google service account can have only 32 characters in a name. So if you do dash production, that's 11 characters, which leaves 21. Well, then you have to do more dashes, and then you realize that the mobile notification service dash production does not fit in the service account name, which spells issue. Stuff like that becomes a problem because you're not unlimited in your string interpolation schemes. But yeah, so these kind of things you will discover. Do you want a downtime or not? And of course, the proper naming and proper abstraction of services. And again, I have to also comment again, when you do interpolation with environment name as a part of identifier, that's usually used when multiple environments share a same registrar. So for example, if you're deploying everything in a shared cluster, then you would have to use namespaces with dash environment name. Otherwise, how would you deploy two apps with the same name, right? Or you use weak clusters. But for Google Storage Bucket, it's a globally unique name. In RabbitMQ, users and queues are uniquely named per host. So if you have two hosts for two environments, no problem. They can both be called economic. But if you have one RabbitMQ for two environments, then you cannot have two economic. You have economic dash and env1, economic dash env2. So those kind of things become important to think about how do you structure templating for resource names. So yeah, so that is the limitations when importing. We are coming to the end. I just want to mention other tools that we actually tried to use. We tried to use TerraGrunt. We gave up because it was too complicated. And we found way too late that there is a Terraform module releaser that simplifies releasing modules over React Git. It does a lot of nice things, but we just decided to not move our effort to that. But if you ever want to do Git-based Terraform registries and you want to do some nice versioning and wiki documentation, it's a cool tool. And of course, shout out to Atlantis alternatives, because you can also use those as well for your journey. All right. So yeah, I think I covered everything. So just a small recap at the end. Modules are a way to go to share code across environments and repositories. If you don't use multiple repositories, you don't need to do this. You don't need to you can share modules inside the repo. You don't need to do the whole versioning thing. However, designing and migration requires a lot of effort. We spent, again, more than a quarter, actually, migrating production. And we are still not, there are still some small issues here and there that we want to fix, but it's a lot of time to conform the existing structure to the new one. And of course, some automation is required, as I showed you, like a local developer experience or versioning across things. Sometimes you want to build some automation, otherwise you'll do this by hand, which is always a possibility, right? You can just search and replace versions with something new. It will work. But yeah, so this is kind of the takeaway I wanted to give you, and I hope you learned something. So yeah, this is all I had. Thank you. I think we have 5 more minutes, so if you want to ask questions, there you go.
Just want to know the slides.
I can make them available. So find me somehow. I have email. I use Blue Skies occasionally. Or LinkedIn. Come on, refresh. Yes. Oh my God. The joys of Markdown. So if you want to get slides, or if you want to talk to me more, find me on LinkedIn, Twitter. Not Twitter, I don't use X Twitter. Blue Sky, stuff like that. Yeah.
Test. So I have a comment regarding the naming, because this uniqueness, we also have this like 32 characters, 16 characters. One thing we did recently, we start to use, instead of production or test or staging, we just assign letters, because it's 26 letters. So we can save like 5-6 characters from the 16. And the second comment, it's regarding this providers. Like some providers are not perfect, so we still need to apply and then do it again. Like you cannot do it in one step. Like in our case, because we also use the external providers, that's the best we can do is we can help them fix them. But we cannot avoid that. Like in our case, we couldn't avoid double apply and plan, because that's the issue with the providers.
Yeah, thank you for sharing. It was certainly a problem for us in both Terra Grant attempt and this new one. Like the providers are a bit finicky, and they're not all like, some can be mocked, some cannot. They require production ready. It's kind of a hit or miss. Yeah. Thanks, sir. I just want to show maybe quickly how did we actually end up naming our Kubernetes. I think you would appreciate this, but not liked. So our service accounts are named. Oh, seriously. Is there any other question, by the way, while I'm trying to find this? No. Okay, it is. So what we decided to do, we SHA on the service name, and then it's Kubernetes -SHA environment name, because you can always search for it here. But basically, all of our service accounts for Google are unpronounceable. And we're still waiting for that collision to happen. So far, so good. But that was our way to like just let's move over this. Because again, if all staging environments share the same GCP project, or multiple, you just need 2, right? You need to ensure uniqueness, and 32 characters is quite small. So this is nice. It works. Pragmatism. All right. Any other questions? Final question to you guys. If you want to share how you guys do modules or actually multi-repo setup or multi-environment Terraform setup, I would really like to know, because again, after studying for this for the last 3 years, I think this is the only and the best way, but I'm pretty sure it's not. So if you can share, please do so. After, not in front of everyone. So thank you for being here, and I hope you have the rest of the conference in good spirit and enjoy. Have fun, and see you around. All right.